Hi everyone, I'm Dustin. I'm currently developer relation at OpenGuild. Welcome to this tutorial where we dive into Polkadot virtual machine and Substrate. Today I'm going to guide you through how to build and run a custom Substrate node locally. Integrate the Pallet-revive to enable Ethereum compatible functionalities, and then we can deploy interact with Solidity smart contract on PolkaVM. Whether you are the blockchain developer or just curious about Polkadot ecosystem, this guide will give you a hands-on way to explore the Polkadot virtual machine capabilities. Now, let's get started. The table of content, we have three main sessions: building and running the custom node locally, how to add Pallet-revive on the runtime, step by step how to deploy interact Solidity smart contract on PolkaVM. First, we go into set up the custom Substrate node locally. This node will serve as the foundation for our Polkadot virtual machine environments, allow us to run a parachain, eventually deploy Ethereum smart contract. Let's break it down step by step. To kick off, we need to install Rust. Since Substrate is built using the Rust programming language, go to the Rust website and follow the installation instructions for your operating system, and you will have the command to run in the terminal. In my machine, I have installed the Rust, and you can check in the terminals. My current Rust version is 1.84. Next, we go in to grab the Polkadot SDK parachain template. This is a free configure Substrate project that gives us a starting point to our node. Open the terminal and clone the repositories here. In my machine, I have already git clone did the parachain templates. Now we have the code. Let's build it. Run this command to build the project in the release mode. Cargo build -- release. This might take a few minutes. It will build all the dependency and generate the WebAssembly runtime for our parachain. The next step, to run our node, we need to install the Polkadot OMI node. This is the node runner provided the priority. We can install by the commands. In my machine, I have already installed. We also need a tool to generate our chain specification. We define the configuration of our parachain. We need to the command to install the staging chain spec builders. This tool will help us create the chain spec file folder, which our node will use to initialize. Okay, in my machine, I already installed the chain spec builder. Now let's use the chain spec builder to create our chain specification. This chain spec file tell us about the node, how to connect to the relay chain. In this case, we are using the local for starting and set up our parachain with the specific IDs. In this case, we use the parachain ID E1000, and you can I will run this command, and I open the VS Code, and you can see the we have the new file that generate from the command, the change spec, and you can scroll down here. Yeah, this is the genesis configuration for our parachain. With our change spec ready, it's the time to fire up the nodes. Use the Polkadot omni-node command to run the parachain node. You can see the hyphen dev. Put the node in development mode, and the hyphen develop times set to 1 second block time for faster testing. Uh, you should see the logs indicating the node is running and producing the block. Okay. Um, to in to interact with our node, we use the Polkadot JS app interface. Open your browser and navigate to this link I have mentioned here. You can see disconnect to your local node via WebSocket on port 99944. You will see the Polkadot JS Explorer where you can view blobs, transaction, interact with your node runtime. Pretty cool, right? Let's move on to adding Ethereum compatibility with Pallet-revive. Okay. Now go back to the README. How to add Pallet-revive on the runtime. Step 1, we need to include the Pallet-revive dependencies in our project cargo file, where we put the Pallet-revive in the project. We will open the cargo file in the runtime directory and add the Pallet-revive features to the Polkadot SDK dependency like this. And now go to the code, go to the runtime, go to cargo file, and in the default you can see that the Polkadot SDK enable a lot of frame, the frame and HCMs dependencies. Now I will add the Pallet-revive. Okay, this enable the feature Pallet-revive functionality in the Polkadot SDK. You can check out the exact commit for reference on the GitHub at the link here. Oh, sorry, maybe I have some issue here, but basically I will update the README later. Substrate revive. Okay. Um, okay, we have another option. Go to my repositories. Go to the Substrate revise. This is the my working here, and you can see the add the Pallet-revive in the cargoes to most here. Here we go. Here we go. We can go to the commit add the Pallet-revive in the cargo.tomos here. here. Okay, now go back to the main documentation. Next, we need to add the Pallet-revive to our runtime configurations. We open the lib in the runtime directory to make two changes. The first change is that we will define the Pallet-revive in the construct runtime. I copy this, go to and define here. Okay, this assign the Pallet-revive with the instead of 60 in our runtime. Second, um, we will implement the Pallet-revive config for the runtime. This is a bit more involved, but it is where we define how Pallet-revive interact with our runtime. Here is the examples. Here is example how to add the Pallet-revive, implement the Pallet-revive config for the runtime. Right. Go to the config and go to the mode. You can see this file will implement the specific palette for the runtime. For example, like the frame system, timestamp, auto-shift, the balance, transaction payment, pseudos, etc. Okay, now I go to the copy this one here. Okay, I copy this. Okay, this setup things like we set up the chain ID of the EVM compatible chain, deposit calculation for the storage contract, and the important thing is the mapping from Substrate accounts, Substrate address to Ethereum address. It also ensure that only the side account, only the side accounts, only the side account can upload and instantiate the Solidity smart contract codes. Okay. Now we finish how to implement the Pallet-revive for the runtimes. The next step, we need to convert the Ethereum transaction to Substrate and style. Okay, convert Ethereum transaction to Substrate and style, and I copy this. I go to the list here. Okay, this one. First of all, we have a struct the Ethereum implementation for the transaction extension check validation. Then we will convert the Ethereum transaction to Substrate intrinsic by this code. I have a note here. What is the unchecked intrinsic? Unchecked intrinsic it normally is the side the transaction, but requires some validation check before they can be accepted in the transaction pool. Any unchecked entry contain the signature for the data being sent plus some extra data. Yeah, you can see that we have a check the nonce, have a check the genesis, have a check the um, transaction fees, etc. Okay, now we go to the next step. We will add the revive runtime API to fully enable Ethereum compatibility. We need to expose the runtime API for integrating with the EVM, like getting the balance, getting gas price, or deploy the smart contract. This API includes a lot of functions such as ETH Gensic for the RPC, Ethereum RPC compatible, or the con or instantaneous with the runtime API. Okay, you can refer the comics the at the revive runtime API here. I will copy the main code from the commit here. Here we go. Here. And go to the file the APIs. Scroll down, go to the bottom, live code, and add the piece of code for the implement the runtime revive API for the runtime. You can see we are able to get the current balance of the ETH address, or the current the block limit of the specific block, or the gas price, or current gas price, or the current nonce of the curve. Then we have the ETH transact is the runtime API that we can call directly from the RPC server, or the call on instantaneous upload code, get storage, trace block, and trace the transaction. You can see this is they are the main functionality for EVM compatible in the um, substrate when we integrate in the Pallet-revive. Okay, now we check the builds. Sorry, we check the build cargo build hyphen release. I think we got the issues when we build the project, because I believe that we have missed a lot of importing dependencies, necessary importing necessaries. Okay, let's fix step by step how to fix the bug. Basically, you can refer in the GitHub OpenGuild Labs. OpenGuild Labs is the open source Web3 community for the Polkadot. You can go to OpenGuild Lab organization, and you can see a lot of open source repositories for the um, for the for the learning and for the learning and the challenge code in the Polkadot ecosystem. Okay, the first issue that when we copy from the readme to the okay, if you don't want to spend more time, just giggle on the main substrate revive node here. I have a conflict how to integrate the Pallet-revive without any bugging, and you can feel free to run the substrate node and ETX RPC servers. And okay, now we take a bigger time to okay, now we will step by step. First of all, you can see we missing the vector. Now we go to using the alloc in the APIs here. Okay, and you can see we are missing the block number. In the block number, you block number. Okay, x 160, we use the epicore h. We can use epicore x. Okay, let me check. Okay, it's work. So it's missing the revive in the API. We will import from the super here. Okay, to revive. Okay, let's check. Go to definition. Okay, it's work. So the revive. Okay, revive. It's okay. Blockways. Okay, we will import from the frame system limits blockway. Frame system. Your frame system limit blockways. Okay. Okay, we missing the display info. We give frame support, display frame support, display infos. Okay, we missing the uncheck and uncheck. Okay, in the APIs file. Okay, we can import the from the suppose. Okay, the revive the runtime origin, the same runtime origin. Okay, we have import the runtime origin. Runtime blockways. Let me check with the runtime blockways. Okay, we can import from the runtime blockways. Here, okay, we can build again, and you can see how many errors in the previous. With the 44, now we have the 15 previous error. Okay, so no runtime. Okay, in the config runtimes. Oh yes, in the config runtimes. Configs. Okay. You 256 U556 in the API. Okay, I think we it's U56. Okay, we will import the each extra implementation from the super. Okay, here we go. We missing the unique we user use. Correct. Unique. Okay. The mealy unique for the configure the micro unique. Okay, nothing. We will from the trace nothing. Yield frame and suicide also. We can use correct from frames. Use frame support trace nothing trace nothings and suicide use frame support. I think the system ensure suicide. The timestamp is missing. The config mode timestamp transaction payment. Okay, you can see that we have in the API we have used the address mapper either associate tray in the Pallet-revive. We need to import the implementation in the address mapper. Okay, go to the APIs and we can go to the runtime here, cargoes API. Okay, we will import the Pallet-revive EVM runtimes. Okay. Okay, we have the 10 with the encode. We need to import the encode from the code that with the storage claim, the transaction payment and suicide in the mode config. In the mode config and suicide in the mode config and suicide here and suicide print system mode config. Okay, and suicide okay. We are missing the transaction extension in the API, right? The API the transaction extension from the tray runtime, the API. Okay, transaction extension. Okay, in the mode we meet the transaction payment. In the mode we will add the transaction payment and timestamp. The mode, okay, the mode add the transaction payment timestamp. Okay. Okay, and we are missing in the mod also. In the mod we will add the super from the, okay, I will in the mod. Super. Okay, we have only 4 in the mod. In the config mod, you using grab and web notching. Okay, I think I have done with the fixing the bug and wait a few minutes to finish building the project. Maybe this I need to remove the from the API here. Note is unnecessary package. Okay. Finally, we have to fix the bug after we migrate the code from the documentation to the current project. Now, for the font, now for the final part is the steps by step how to deploy and interact Solidity smart contract on PolkaDot machine. Right now we are enable the Pallet-revive, right? The Ethereum compatible functionalities in the Substrate node. The PolkaVM will allow us to run the Ethereum compatible smart contract like Solidity, and so let's see how to do it. To interact with our node via Ethereum Star RPC, we need to install the Revive ETH RPC tool. To install it, we use this and go to the install here. From my machine, I have already installed. Make sure that you install the correct version of the Revive ETH RPC because it will be compatible with the Substrate node version, the Polkadot SDK version that you are using in your project. Now let's start our node, the Substrate node and the RPC server. Okay, first we run the node with debug login with the Pallet-revive here. The parameter, the flag that I have explained before. Now open the another terminal and start the Revive ETH RPC. Okay, by using the command. Oh, sorry. Oh no, this is the ETH RPC hyphen dev palette with name Revive not found. Oh, sorry, I think I have some mistake where no search file. with ATX RPC in the bin. No such file the ATX RPC. Oh my god, why is not working? The metadata data with the name revive not found. It's very weird. Let me go to the Polkadot again. Go to internship. Go to the. Okay, I don't see the Pallet-revive. Collect. Remove the old cake data. Let's try to remove that. Okay, I don't see the Pallet-revive. It's very weird. Delete the Pallet-revive here. I already. Sorry, I will build the project again, and I think regenerate the change spec again. Waiting some minutes to finish the build. Okay, let's use the command to build the change spec again. Now under here, let's see, refresh the Polkadot CS Explorer. Oh, it's very weird. Why I don't see the Pallet-revive? Okay, we are able to subtract in from the substrate node. Okay, we will to erase the cache data. Now, yeah, here we go. We finally find out the revive. Okay, what is the next step? Okay, after we run the substrate node and the ETX RPC compatible in the dev mode, now we are able to check the RPC connections. Okay, we will make sure that the RPC server is working, so then we are able to use any kind of Web3 tools such as enthusiast, Vim, MetaMask, any materials related to Solidity. Okay, let's me using the curve to check now. Okay. You should see the JSON response with the detail about the elastic block, like the block hash, the Gallimid timestamp. This confirm our RPC server is up and running. Okay, very good. To interact with our node using the familiar tool like the MetaMask, let's add our local network. Okay, open the MetaMask, go to the add network, and enter this detail that I show in the documentation, and go to the MetaMask. Basically, I have add the network, the substrate node revive in the MetaMask. Okay, and you can see that the balance is 0, right? The Ethereum address is 0. How to deposit the fund to the Ethereum address? Okay, because Substrate and Ethereum use different account formats, we need to map the Substrate account to Ethereum address. So we go to GS Explorer go to GS Explorer, go to internship and choose the Alex. um, if you don't have a Alex account, uh, I send you the private key, the Alex Substrate private key. Here we go. This is the well-known account in the Substrate Polkadot ecosystem. And how do you import the Alex in the Polkadot GS Explorer? The wallet integration. You can go to accounts, go to vanity generators, and you choose the HR. Okay, and start generation. So choose specific address here, say, and put the Alex private key here. For example, here we go. Now I have say the minor simply and put the, you can see I have already import the Alex account in the Polkadot GS Explorer. Or you have another choice that you can use the sub wallet extension or any kind of wallet extension support Polkadot ecosystem. Okay, so how to map Substrate account to Ethereum account? Go to developer internship and go to the revive and go to the map account internship. Okay, this is the function that you will map the Alice Substrate account to Ethereum address. Sign and submit the transaction. Okay, so then we will use the MetaMask tool to deploy smart contract, right? So we need a fund. Okay, how to free fund or deposit to the Ethereum address. Okay, we can check the documentation here. Go to the Polkadot GS Explorer, internship. Okay, revive and choose the con internship here, and destination is your ETH address. Okay, I will take ETH address. Okay, and the value, this is one in the way. Okay, basically did the template have a consist of 12 token decimals, and I will deposit 1000 revive 1000 native tokens to the Ethereum address, and you need put the storage deposit limit here and the data for the simple transfer. Now go to the submit transaction. Okay, the transactions were successfully, and go to check the MetaMask again. Now the Ethereum address have a 1000 native token revive. Okay, that's good. Finally, let's deploy the Solidity smart contract using the remit. This is the version remit for the Polkadot virtual machine, and you can go to the remit and the remit.polkadot.io. Okay, it means that you can deploy Solidity smart contract on the Polkadot virtual machine, not Ethereum virtual machine. On those, it is the same Solidity code, but it's different virtual machine architecture. Now, go to the specific simple storage contract, and I go to storage, then I will go to compile the storage here. Now I go to deploy and run the transactions. So I choose the injective provider with my Substrate node revive Ethereum compatible RPC. Okay, you can see that the accounts aren't showing in here, so we need to, I think we need to disconnect again, and let's trigger injected provider again. Okay, finally the account show here. Okay, although the account show zero native token, but don't worry about that. So let's deploy the Solidity, the storage contract on the Polkadot virtual machine. I confirm. Okay, here we go. We have a deploy successfully with the storage here, and go to the I go to retrieve 0 for the default on-chain storage, and I will go to set store here. Okay, and I am able to execute the transaction to update the store on-chain storage. Now I retrieve again. We see 10. Okay, good job right now. Okay, there, here we go. We have it. We build the custom substrate. We build a custom substrate node, added Ethereum compatibility with the Pallet-revive, and deploy Solidity smart contract on the PolkaVM. Okay, this setup opens up the tons of possibility for building cross-chain decentralized application with the power of Polkadot and Ethereum compile. If you found this helpful, drop a star here and fork the repos. Let me know. Let me know if you have any questions. Happy coding. You can go ask me Dustin OpenGuild in the Polkadot Discord or OpenGuild Discord.